Okay, so we are looking at similar triangles still, and today we're actually going to finally look at some similar triangles, whereas we haven't actually looked at that yet. Okay, so day 3. Similar triangles. Identifying similar triangles, here are 3 ways to show that triangles are similar without having to show all 3 sets of angles are congruent and all 3 corresponding sides are proportional. Okay, the first one is called AA similarity, and it's 2 angles of one triangle are congruent to 2 angles of another triangle. So if I look at these triangles, I'm going to zoom in because they're really tiny. I can see by matching arc marks that angle A and angle D are congruent. And I can see angle B and angle F are congruent. And with 2 pairs of congruent angles, that's enough to say you have similar triangles. We don't know if we have congruent triangles, but we definitely have similar triangles. If 2 pairs of angles are congruent, you have similar triangles by angle-angle similarity. Okay? And the reason that is because if you think about 2 triangles that have the same angle measurement, for example, let's talk about the equilateral triangle. If I have 60 degrees, 60 degrees, 60 degrees, and then if I enlarge that and still have 60 degrees, 60 degrees, 60 degrees, it's going to be proportional. It's still going to be equilateral. My sides will all be the same scale factor. Okay? If you know 2 of the angles, if I need to find the 3rd angle, if I add these 2 together to subtract from 180, when I add these 2 together, I'm going to get the same thing over here because I'd be adding the same 2 numbers together, right? So when I subtract the same number from 80, then my 3rd angle is going to be the same. So the triangles both for sure have the same angles. Okay, if I can prove 2 of them are the same, I don't have to worry about the 3rd. And then as my triangle gets bigger or smaller, the sides are going to stay proportional if the angles stay congruent. Okay? And then just remember that your order is important. So when we write our similarity statement, you need to say that it's a triangle. And then you just name your first triangle. It doesn't matter in this case which one we want to say is first. I'm just going to go alphabetical ABC. Is similar to, so we use our little similar symbol. And then if I start with my single arc here, I use the matching one here, D. Triangle, don't forget to say it's triangle, D. And then from A I went up to B, so from here I'm going to go D up to F, and then to the unmarked angle E. And we say we know this because of angle-angle similarity. So remember when we did side, 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 and side, angle, side, and all of that, I would say you should put the congruent symbol afterwards. Because now we're sometimes using the same letters if you look at the next 2, and we need to know we're talking about similarity and not congruence. Okay? For example, when I look at the next one, okay, the next one is called SSS similarity, and it says the measures of the corresponding side lengths of the triangles are proportional. So just like yesterday we talked about being proportional, you set up the corresponding sides, and if they all reduce to a same scale factor, then your triangles are similar. And this time we wouldn't have to look at the angles, we only have to check the sides. So if this one doesn't have actual like markings, this one I could for sure say it. But here we're going to say if. I'm going to go with A. I'm going to say that they're in the same, sitting in the same orientation. So I'm going to say if A it corresponds to Q, and if that ratio is equal to B corresponding to R, and if that's equal to D corresponding to T, if all of those are equal, then not only do we know a scale factor, we know the triangles are similar. Triangle, I can call the first one ABD, would be similar to triangle. If I start at A, I'm going to start at Q. And from A, I went up to B, so I'm going to go R, T. We checked that the 3 sides were proportional, so by side, 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 similarity. And that's only if you get the same fraction when you reduce your fractions. Okay, so if you don't like reducing, you probably should have picked up a calculator. Not one calculator got picked up today. Okay, we were excited about the new seating chart. All right, the last one, side angle side, SAS similarity. The measures of two side lengths of one triangle are proportional to the measures of two corresponding side lengths of another triangle, and the included angles are congruent. Okay, so when I look at two sides, DE and DF over here, and then HK and HJ. Notice they both involve H. These both involve D. So that has to be my congruent angle, and I can see it is. So where they come together, that has to be the angle that's congruent, where these two come together. If it's not, then your angle side, and remember we don't trust the booty. We don't know that that works. Okay, so it has to be the angle in between the two sides that we're checking. So when I look at this one, we can say if, for sure we know D is congruent to H because they have those same arc marks. If angle D is congruent to angle H, and we have to have the two sides that come out of D and H proportional. So F proportional to J, or a ratio to J, needs to be equal to E compared to K. If those angles are congruent and if those two fractions are equal, then triangle, my first triangle DEF, would be similar to HKJ. Triangle HKJ. Questions? Okay. Let's look at some examples. Okay. So when I look at these first two triangles, I don't know anything about the angles, but I do know all three sides of both triangles. I know all three sides of both triangles. I don't know because they didn't say is triangle ABC congruent to triangle DEF. So they didn't give me an order to compare. So what I have to do is I know that my shortest side should match up with my shortest side, right? My longest side should match up with my longest side, okay? So what I like to do, and I recommend it especially, sometimes you end up with triangles inside other triangles, I draw my triangles separate. Here they're already separated for me, and then I label them small, medium, and large. Okay, so my first triangle over here is small, medium, and large. Okay, and then my second triangle over here, the 9 is small, the 12 is medium, and the 15 is large. So then when we compare them, we compare small to small, medium to medium, large to large. And you have to always make sure you're paying attention to which triangle you're going to put in a numerator and which triangle you're going to put in the denominator. So you pick one. I'm going to go with the first one just because it's on the left-hand side. Make that my numerator and the other one the denominator. Okay? So my left triangle is always going to go on the top of the fraction. My right triangle is always going to go on the bottom of the fraction. And I want to see, are my three sides proportional? Do they make the same fraction? Okay? So my small here is 6. That's going to match up with the small here, 9. My medium is 8. That's going to match up with my medium, 12. My large, 10, matches up with my large, 15. And then we just want to reduce those three fractions. If they reduce to the same thing, then we say yes, they're similar. If they reduce to different things, then we say no, they're not similar. Okay? So 6 over 9, 3 goes into 6 2 times. 3 goes into 9 3 times. 8 over 12, 4 goes in there once, 4 goes in there 3 times. Oops, sorry, 2 times. So far so good, 2/3, 2/3. And then 5 goes in here 2 times, 5 goes in here 3 times. So 2/3, 2/3, 2/3, yay. They are proportional. So we can say yes. My triangles are similar. Triangle ABC is similar to triangle. Now here, this is the important part. These are pretty easy because if you look at small, medium, large, they're set up in the same exact, they're orientated the same. Neither one's been kind of rotated around, so this one's pretty simple. But when they're rotated, you really want to look, okay? So A is here between the small and the large, so I need to make sure I'm looking between the small and the large, so I know I'm starting with D. And then from A I went to B, so I went across the large side. So I'm going to go to E, and then F. In this picture, you probably would have gotten it right just by guessing the order, but on some of them you won't. You really need to look at what two sides is it between. Small and medium, small and large, large and medium, what two sides is it between? Okay? Alright, let's look at the next one. For the next one, we don't have all three sides. So on this one, I'm not going to be able to use side, side, side similarity. Okay, I'm going to have to use either angle, angle, or I'm going to have to use side, angle, side. Since I only have the 70-degree angle, I'm not going to use angle, angle. So I'm going to have to use side, angle, side. When I look at this, I can see I know a 3 and a 6. And the 3 and the 6 come together right here at the 70. And on my second triangle, I have the Q, R is 4, and the R, S is 8, and they come together right here at 70. So they come together both at 70, so that's good. And then I need to make sure I compare the small side to the small side and the big side to the big side, right? So out of 3 and 6, 3 is small, 6 is large. Out of 4 and 8, 4 is small, 8 is large. So these are still nice and evenly oriented, so these are actually going to be pretty easy also. I already know my angles are the same, I just need to check these two sides. So one side and a second side. My small is, oh, I didn't put arrows. I'm just going to do the one on the left as my up. That's generally what I usually do. And the one on the right is the small. So small is 3. Matches with small is 4. I should have done this in green to match my picture. Okay? And then my large is 6. Matches with my large, which is 8. Reduce those and see if they reduce to the same thing. Okay? So when I reduce them, 3 over 4, that doesn't reduce, it stays 3 over 4. 6 over 8, 3 goes into 6 2 times. And, oh no, we don't want to do 3. 2, right? 2 goes into 6 3 times, and 2 goes into 8 4 times. They do reduce to the same thing. Okay, again, if you don't like reducing, your calculator will do it for you. You don't even have to think. Okay, these did reduce to the same thing, so these triangles are similar. Yes. Triangle M and P is similar to triangle. If I started at M on the end of my small side where it doesn't come together, I'm going to start at Q. And then from M, I'm going to go to N, my 70-degree angle. So from Q, I'm going to go to my 70-degree angle R and end up at S. Order is important. I could have picked the first order. I could have done M, N, P, N, M, P, P, N, M, P, M, N, whatever order I wanted to do. Okay? Questions on those two examples? Okay. Okay. Let's look at the next one. All right. On this one, since I see two angles marked congruent in each triangle, I'm going to use angle, angle, right? I've got angle A is congruent to angle D, and I've got angle B is congruent to angle E. So we're going to say, yes, they are similar. By the angle, angle, similarity postulate. Okay? So now I just need to make sure I line everything up. Triangle A has my single arc mark on it, so it's going to match D. AB. B has my double arc, so I'm going to go to E and then end up at F. Now on this one, then it asks for the scale factor, but I don't have any numbers, so that means I can't find it. I don't have enough info. I don't have enough info to find the scale factor. I need at least one corresponding side from each triangle in order to find the scale factor. Okay? Questions on the first one there? Alright, let's look at number 2. On number 2, I only have one pair of angles. I have those 90-degree angles, the L and the W. So I know I have one angle, but I don't have two, so I can't use angle, angle. I have two sides from this triangle, and I have two sides from this triangle, so I can't use side, 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 because I only have two sides. Well, I guess I could. I could use Pythagorean theorem and try to find the third side. But I don't want to have to do that, because since I have two sides, and those two sides are where the triangle comes to the 90 degrees on this one, and it's where the two triangles come to the 90 degrees on this one, I can test for side, angle, side. Okay? Remember, we're going to compare the small with the small and the large with the large. So over here, 18 is smaller than 24, which is larger. So when I compare them, I'm going to compare small to small. I'm just going to put the left triangle on the top, and I'm going to put the right triangle on the bottom. You can switch that up, it's fine. Actually, this one we probably should, because it says JKL first here. So we should put JKL on the top since it comes first. It should be on the top. Okay? Alright, so I'm going to compare small to small. I'm going to compare large to large. 20 over 18. What does that reduce to? 10 over 9. 36 over 24, what does that reduce to? 3 over 3 over 2. Right, we're dividing both by 12. 36 divided by 12 is 3. 24 divided by 12 is 2. Do those equal each other? No. No. Which means I'm not going to check a yes here, which means I cannot fill any of this out. I have to leave it blank, because I'm just going to say no. They're not similar. I can't write a similarity statement. If I put something in this box, it's for sure wrong. I cannot put something here because they're not similar. Which means if they're not similar, I'm not using, I tested a postulate, but I'm not using a postulate. And then there's no scale factor because they're not similar. Right, so I leave all of those blank. Alright, let's look at the next one. Okay. Here I have what we call nested triangles. I have one triangle nested inside another triangle. And the only thing I know is that two sides of them are parallel. Okay, when I have nested triangles, I guarantee you it's going to be easier if you redraw them separated. Okay, it's going to be easier if you can redraw them separated. So I'm going to take this smaller triangle and I'm going to draw it. So this is the one with the parallel side, where I've got an S here, an L here, and a T here. And then I have the bigger triangle with the R here, the U here, and the T here, and parallel. Remember when you have parallel, that's going back to that unit 2 we did where we had the parallel lines and transversals. So we had things like corresponding angles and alternate interior angles and alternate exterior angles are all congruent. We have same side interior angles are supplementary. So those are things we want to look for when we have parallel lines. Okay? But whenever you have what we call nested triangles, the corner that they're nested in, if you notice, when you look at the corner that they're nested in, those corners, this T is here, right? That's that triangle. That T is also the same angle for this triangle. So I do have one angle that's congruent. Since I don't know any sides, I need to show another pair of angles that are congruent. Any idea what other pair of angles we could show are congruent? R and S. R and S. So if I look over here, that would be this one and this one. If I think of this as just parallel lines and not as triangles, and then think of this where R and S as the transversal, and I just look at just that part, what is the relationship between those two angles?
Corresponding.
They're corresponding, right? That's how we know they're the same. Corresponding angles with parallel lines are always congruent. So yes, R and S are congruent because they are corresponding angles of two parallel lines crossed by a transversal. Okay, so yes, we can say that, which means are these triangles similar? Yes. RTU, so R has the double arc, which means we're going to start with S, with the double arc. T, I came to that nested angle, so T. And then U, L. By which postulate did I just test? Angle, angle, similarity. And then what about my scale factor? Not enough information. We need two side lengths that are corresponding to find the scale factor. Okay? All right. Moving on. Number 4. Which postulate am I going to have to test for number 4? Side, side, side. Side, side, side. So that means I need to look at one triangle and identify its small and its medium and its large side. And then I need to look at the other triangle and identify its small, its medium, and its large side. And then when I compare the two triangles, I need to make sure I compare small to small, medium to medium, large to large. Okay? So GHI comes first in my similarity statement if these are congruent. So I'm going to make sure that I put GHI on top so that way when I have my scale factor, it's not upside down. So then I'm going to put this one on the bottom. Okay? All right. So I'm going to put this one on top. Let me set up my proportions. 3 fractions, small, medium, and large. My small side 24 will match my small side 15. My medium side 32 will match my medium side 20. And my large side 40 will match my large side 25. And then I just need to reduce those fractions and see, do they reduce to the same thing? 24 over 15, 8/5. 32 over 20, 8/5. So far, so good. And 40 over 25, 8/5. Are they similar? Yes. Triangle GHI is similar to triangle, so G is between small and medium, so between small and medium is Q. And then from G I went to I, so from G I went across the small, so I'm going to go from Q to S, and then up to R. By which postulate did we use? Side, side, side similarity. And what's my scale factor? 8 to 5. And then I don't check that bottom because they are similar. All right. Questions on 4? Flip this around, make this a little easier for myself. Okay, so here I have another set of nested triangles. And I want to do two things. One, I want to identify which triangles are similar. Okay, so I want to make my little similarity statement. Triangle ABD is similar to what? Okay. And then I want to find the indicated sine length others. So then I want to find CE. How long is this little piece right here? Okay. So the first thing I highly recommend you do is separate the triangles into the small one and the big one. Okay. So my little triangle right here, CED or CDE, however you want to say it, or DEC. This little one, DCE, where C to D is 6 and E to D is 3. I don't know CE. I want to eventually find that. Okay. And then I have the whole big thing, ABD. The whole big thing, A, B, D. AB is 16. How far is it from A all the way to D? 24. Segment addition postulate, 21 plus 3, 24. How far is it from B to D? 12. 6 plus 6, segment addition postulate. Okay? Do I have any congruent angles to try to test angle-angle? Do I have any congruent angles? Yeah, which ones are congruent? The nested one, right? So always check. If you have nested triangles, you're always going to have at least one congruent angle. So I definitely have angle D is congruent to angle D in both of them. But since I don't have parallel lines or anything, I don't have a way to find a second angle, so I'm stuck there. So I can't test angle-angle. I can't test side, 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 because in the little triangle I only know 2 of the sides. So that leaves me with what? Side, angle, side, right? We have to get a little sassy here. All right, so I'm going to check side, angle, side, which means I need to look at the 2 sides on either side of D. The 2 that come out of D are 6 and 3, where the 3 is small and the 6 is large. On the other triangle, the 2 that come out of D are 24 and 12, where the 12 is small and the 24 is large. So when we compare them, we have to compare small to small and large to large. We get to pick, because it's not asking me for a scale factor, we get to pick which one's going to go in the numerator, which one's going to go in the denominator. Which one do you want to put on top, the small one or the big one? Say it one more time. Which one? Small. Okay, I heard more smalls the second. I don't think I heard any bigs the small the second time. All right, so we're going to go with the small one on top. You'll get the same answer if you do the other way around. And the big one on the bottom. So when I compare to see if they're equal, I'm going to compare the small 3 to the small 12. And then I'm going to compare the large 6 to the large 24. Three over 12 is 1/4. 6 over 24 is 1/4. So we found our scale factor, and we know these are similar by SAS similarity. Okay, so triangle. What do you want to name the little triangle? CED? CED is similar to triangle. If I started at C on this triangle, where am I going to start on this triangle? Where? If I start at C on the pink triangle, where am I starting on the purple triangle? Why A and not B? B is at the top, C is at the top. Right. Remember, you have to make sure you're not lining up how they're sitting, you're lining up them by size, right? So when I look at the congruent, oops, I turned that off this morning, but it only has a 2-hour time limit that it'll stay off. Okay. So you have to compare the sizes, not how the triangles are sitting. So if I leave D and go across the large side, that's how I get to that first letter C. So that means I have to leave D and go across the large side to see where to start. I have to start at A. That's why it's so important to redraw and label your triangles. Otherwise, if I just looked at it like this and hadn't separated it apart, I would for sure think that C matched with B and that E matched with A, but it doesn't. C matches with A, which means E matches with B, right? Because from C I go to E, so from C I go across the side that I haven't written on. So from A I'm going to go across the side that I haven't written on to B. And then I'm going to end up at the congruent angle D. And we know they're similar because we tested by side, angle, side. Similarity. Alright, we still aren't done. What do I still need to do? Yeah, it wanted me to find CE. When I look over here, I know that CE corresponds with what? AB. So CE is in my up arrow triangle. So it's going to go on top. And it matches with AB, which is in my down triangle. So it's going to go on the bottom. And what should that fraction reduce to? The scale factor, 1/4. I can solve that, right? We just cross multiply. When I cross multiply, I'm going to get CE times 4. I do it like this. I'm going to get 4 times CE is equal to 1 times 24. Oh, not 24. What is it? 16. It should be AB. I don't know why I looked at AD. CE, come back over here. CE matches with AB. So CE matches with AB, the 16, not the 24. 16. 1 times 16 is 16. So then we divide division property of equality. How big is CE? It's 4. We don't know our units. You can write the word unit after it if you want to. 4 units. So again, if you have a triangle inside another triangle, I highly recommend redrawing them. Okay, if you need scratch paper, I have plenty of scratch paper. All right, number 6. Last one for the notes today. First thing I want to do is see if I can test angle, angle. If I can't, then I check side, side, side. If that doesn't work, then I try side, angle, side. If it doesn't match any of those, then I don't have enough information. Okay? Do I have any angles congruent in this picture? Yeah. Which one? B. The angles at B, right? How do I know the angles at B are congruent? They're vertical. So angle ABC and angle EBD. I can't just say angle B is congruent to angle B. That's the reflexive property. It has to be the exact same angle. So, right, because there's really 4 angles at B there. Okay? All right, so I need another pair of angles if I want to test angle, angle. Do I have any other angles? Any other angles? What do I notice in that picture? What do those black triangles mean? It means they're parallel. So that means this piece here, AC, is parallel to this piece here, ED. That's not dark enough. Oh, my watch is trying to call either Edward Kern or Edna King. No, don't call them, because I said Ed. So I've got these 2 lines that are parallel. Do I have any transversals? I have two transversals. I have A to D as a transversal. Let's just say I just look at that one. Do I have any congruent angles? Yes. Well, I have plenty of congruent angles. Which ones are going to be helpful if I look at this picture? A and D. Right? If I were to erase this back out now. What type of angles are those? How do I know those are congruent? What do we call those? Alternate interior angles. My alternate interior angles are congruent. So this angle here, A, is congruent to this angle here because alternate interior angles with parallel lines are congruent. Okay? All right, so can I prove these triangles are similar? Yes, by angle similarity. So triangle ABC, I'm just going with ABC, is similar to triangle. If I started with A, that's the one I put my double arc marks on. What's that going to match up with on my right-hand side? D. And then from A, I went to B, so I went to the intersection of the two triangles. So I'm going to go from D also to B, which means then I'm going to end up at E. So now that I know I have a similar triangle, and I still don't know a scale factor, but that's okay. I do know what sides are proportional. So I need to use that idea so that I can solve for x, right? I know that AB is going to match up with what? DB. So AB is 23. And I know it's going to match up with DB, which I don't know what it is. Okay? I know that BC, the one I'm trying to find, X, matches with what? With what? BE, which is 38.6. I know that AC, which is 30, matches up with what? With DE, which is 60. What's my scale factor? I can't reduce that one to find it. I can't reduce that one to find it, but I could reduce this one. What's 30 over 60? 1/2. So I know all my fractions are going to reduce to 1/2, right? So when I want to find x, I want to find out how long BC is. All I have to do is set that equal to what? 1/2. So x over 38.6 is equal to 1/2. Cross multiply 2x equals 38.6. Divide both sides by 2. 38.6 divided by 2? 38? How much? 19.3. There's 30 calculators sitting right over here. There's 27 of you. That means there's 3 extras. 19.3. There's my 2 answers. Oh, I didn't say how we knew this. By angle similarity for the last one. Okay? All right, your assignment is available for you in Schoology.